Hey guys, it's Professor Knight here. I'm making a video to help you guys with your linear perspective drawings. I've got my cell phone strapped to this weird selfie apparatus, so if it bounces, sorry, I'll try to keep it to a minimum. Hopefully none of you get motion sickness. So we're working with linear perspective this week in class, and what I've noticed is that a lot of you do a great job when it's theoretical, when you're using linear perspective and vanishing points to invent a space or just create a bunch of boxes like I've done here. The harder thing to do is to apply those principles to an observed space, like this one. I regret that I don't remember the artist who made this. I pulled it from the internet, but you can see it's got very clear one-point perspective, nice vanishing point, nice orthogonals, which are those lines that point towards the vanishing point. And then we wind up in a place like this, a three-dimensional place, where we have to find our own vanishing point and orthogonals and all that. So this tutorial is designed to help you with that. So the first thing I would do would be pick my view and identify your orthogonals. So that might be, and I'll get my little pointer ready, orthogonals are lines that are parallel in the real world, but appear to converge to a point when they occupy depth. So like these are orthogonals. If we look up, that is an orthogonal. That is an orthogonal. All these lines in the ceiling, the width of the lamps, the tops of the doors, if we connect them, all of those are real world parallel. Like this door back here is not actually smaller than this door right by my face. Real world parallel, but when it occupies the depth and we're dealing with it in 2 dimensions, it gets sucked to a vanishing point. So we're going to talk about how to find that vanishing point when you're looking at an observed space. So I've identified my orthogonals. That's step number 1. Step number 2 would be to think about my composition. And for that, I can use my phone, the rectangle of my phone. This rectangle on my phone is a little bit longer and skinnier than the rectangle of my paper. So I could also use a viewfinder or my handy viewfinder fingers. And so to do that, you turn one of them this way and you put them together, and there's that. So I'm going to frame up a view. All right, there's my view. And now what I'm going to do is figure out where my orthogonals run into the edge of my rectangle. So if you look at the bottom 2, you can see that they are hitting the rectangle on the bottom edge of the rectangle, of my rectangle. I guess it's more like that. They're hitting on the bottom. They don't go all the way to the corner. They don't hit the horizontal sides at all. They hit the bottom, like there and there. So I look down at my drawing and I make a little mark. Let's say here and here. So I know that the orthogonals that I'm about to cite are going to start here and angle towards the middle somewhere. All right. Oh, and notice that I have 2 devices here. I have my pencil and I have a straight edge, which in this case is a ruler. I'm going to leave the straight edge down here. Okay, so I've got my orthogonals. Remember, I'm going to start with these 2 at the bottom. Double check myself. Looks pretty good. Sorry, technology breakdown. There we go. All right. Okay, so now I'm going to cite, just like I've been doing all semester. I've got my pencil. I could hold it out like this, like we've been doing in the classroom. Here, you can't see me, but my arm is fully extended. But the problem when I get to that is I run into the table before, there's not enough space to fully extend my arm. So what I prefer to do, instead of extending my arm all the way, is keep my arm kind of locked to my body. So now I'm just citing right in front of my nose. And my arm is hugged into my side. Remember, the less we move, the better. So my arm is totally hugged into my side and I'm not going to move it. So I'm citing that line, that first orthogonal. Boom. All right, now I'm just gonna pivot. I'm gonna look down. Notice I'm holding the line in space. I'm never directly applying it to the paper. Notice that the pencil stays next to my face, close to my nose. I use my second straight edge to line it up. See how they line up perfectly? I know that the bottom corner is on that dot that I just made. So that's good. Now I'm gonna make a line. And usually I like to double check myself because, you know, we make mistakes. Before I move that. Do-do-do-do. Perfection. All right, now I do the other one. Same thing. I'm gonna hold it right up close to my nose. And I'm gonna line it up in space. Pivot. My pencil doesn't move. I'm just moving my upper body, my torso. I put my ruler on that dot. Can you see the dot? I know it's kind of fuzzy, but there's the dot. I'm gonna angle it so that the angle exactly matches my pencil. I'm running into the bottom edge of my own paper. There we go. Pretty darn good, huh? Now I make this line. Do-do-do-do. So there are my orthogonals. And I also have my vanishing point. That is the point where my two orthogonals meet, where all of my orthogonals that are parallel to the bottom of the hallway meet. While I'm here, I'm going to take a minute to just make a parallel line, sorry, not parallel, a horizontal line through this vanishing point. This is my horizon line. This is at my eye level. So I'm just going to mark it with a little eyeball here so we remember. Oh, that's terrible. Anyway, so there's my eye level. So other future vanishing points, like notice that cart thingy is not square to the rest of the room. It's kind of askew. It's like a little bit twisted. So it will have its own vanishing point that will not be the same as the one that I got for this, but that vanishing point will be on the same horizon line. So even if you have a 1-point perspective, it's helpful to just go ahead and put your horizon line there. It's helpful to remember that things above the horizon line angle down, things below the horizon line angle up. All right, so there we go. Now if you look, where's my, if we go back to my composition, the top is very narrow. This like selfie device is pointing slightly down. My eye level is probably about here, right? So anything above that line angles down. Anything below it angles up. All right. So let's go ahead and we're gonna draw the door just for reference. The door's pretty small. This is the back wall. The door is sort of to the, on the left side. I'm trying to keep my horizon line roughly at my eye level. And then I don't necessarily even have to cite these. I can if I want to. So there's the line. If I did it right, it should meet at my vanishing point. And it does, look at that. It goes, check it out. Vanishing point through the corner of the wall and up. So this now is that wall over there. And when I come back in a second, I can do the doors. I'm gonna do the second wall without citing. I know that I'm gonna start at the vanishing point. I've already established where the corner of that wall is. Boom. Pretty rad, huh? Maybe I wanna make this. A little bit. There's a little bit of a disconnect here because I'm not looking directly at my drawing. I'm looking through the screen, so it's a little bit funky monkey. Okay, all right. Now let's do the tops of the doors. So I'm gonna anchor on my vanishing point. The doors are above my eye level. The tops of the doors are above my eye level. And they're pretty close to the top of that wall. So I've got my point. Dun, 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 dun. I'll go ahead and do the doors on the other side. What have we got over there? It looks like we've got two really skinny doors to the left and a slightly bigger one to the right. That one may be too close to us. All right, so we've got the top of our door marked. So we've got skinny door, and right next to it is another skinny door. Over here, we've got two together and then one by itself, and then two more a little bit farther apart. If I were gonna take more time, I could do comparative measurements here. So I would know how far apart that other door is. I could do perceptual grid. I'm just gonna darken this in so I can kind of tell what I'm looking at. We could do the door handles if we wanted to. The door handles are all at the same height on these doors. So let's say there's one below my eye level, so it's going to be about there. We know that the other ones are going to be here. It also applies to stuff on the ceiling. So see how the width of these rectangular lights also gets swept to that vanishing point. So let's do that. And notice that it's angled a little bit this way. If it were directly over my head, here, I'm gonna hold this. And I'm gonna very carefully take a step here. Now, see how that side's angled the other way. Maybe this would have been the more informative one to cite. So watch, when I take a step back, the angle of it changes because it's all relative to your eye level. It's now pointing the other way. Pretty cool stuff, huh? All right, so we'll go back to my original view and I'll try to put the lights in. Because of where I cropped it, I don't have a ton of space for lights, but I can fit some of them in. Every time I'm anchoring at my vanishing point, well, just imagine that I have more room at the top of my rectangle. So that's the width of the lights. Now I'm going to draw the individual lights. And then they stop Obviously they don't keep going all the way to the point. They stop at the top of the wall. All right, before I wrap up, let's try to do this guy. So he's gonna go like here-ish. Let's try and get my viewfinder fingers. Whoa. Okay, so maybe we just have room, and because my drawing cuts off before we get to the bottom, so we'll just do the top. All right, here we go. So I'm set again. My arm is like adhered to my side. It's stuck to my torso so that I can't move it. Boom, there's that angle. Pivot, 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 pivot. I'm using the perceptual grid to figure out how high up it is. It's like, it's above my eye level. It's a little bit taller than me. Remember, eye level is here, so I'm going to start it kind of there. Using my second straight edge until it is exactly lined up. Anchoring it at my vanishing point. So there's that, the top of it. The bottom of it is going to go off my page. Oh, I lied. Sorry. It should not, it's going to have its own vanishing point. Let's try that again. I did something wrong. It should not have pointed to that vanishing point. Let's try it again. Dun, dun, dun. There we go. It's a little bit, it's close, but it's a little bit farther over to the left. So the vanishing point for this thingy, remember, vanishing point is the point where, two things. The point where your orthogonals meet. I only have one orthogonal right now. I only have one angle. So it's also the point where your orthogonal meets the horizon line. So that's why it was so important for us to establish the horizon line before. So there's my vanishing point for that weird cart. Now the bottom of it, let's see, it's kind of close to there. So there's the angle that it would follow. Verticals stay vertical right now. And it has little wheelie gigs. Go ahead and get our other vertical in here. I don't know if you noticed, but with this kind of rule, it's really great. I can line this up with the bottom edge and know that that's going to be perfectly vertical. Theoretically, this is a 2-point perspective, but my other vanishing point would be like over here somewhere. So I'm just gonna wing it. So obviously this drawing has some issues. It needs some tidying up. I can diminish some of my construction lines, but you can see that it's a pretty accurate representation. It's a good start, let's put it that way. It's a good start for this hallway that I'm looking at. Maybe we can do a side-by-side comparison. The angles are right. The scale feels the same. I'm standing on the floor. I'm not flying up in the air, or looking down on things that I'm not actually looking down on. So it's a good start. That's how you use citing and linear perspective together to help draw an observed space. Thank you.